In this video, we will talk about the composition of the sine function and its inverse, and this will include the inverse or the cancellation properties and examples. Recall the composition of two inverse functions f of x and f inverse of x. According to the definition of inverse functions, the composition of f and f inverse of x equals x, and the composition of f inverse of f of x is also x. Now notice that each of these properties has some restrictions. The composition of these two functions is x when x is in the domain of f inverse of x. In other words, this expression equals x when x is a number that can be used in this function. In the second property, x has to be in the domain of f of x. So x has to be a number that can be used in f of x. Now let's talk about the sine function and its inverse. We know that if we would have a basic sine function, then the domain would be any number from negative infinity to positive infinity. However, for the inverse properties below, we have to use the restricted sine function, and this function has the domain from negative pi over 2 to positive pi over 2. So in this table, we have the restricted sine function with the given domain and the range, and the inverse sine function with its domain and the range. Notice that because these two functions are inverses of each other, the domain and the range are interchanged. Now let's look at the inverse or the cancellation properties. The first one is sine of inverse sine of x equals x for each x in the interval from negative 1 to positive 1. So this expression will be equal to x when x is a number from negative 1 to positive 1. And this is the domain of the inverse sine function. The second property is inverse sine of x equals x for each x in the interval from negative pi over 2 to positive pi over 2. So this expression will be equal to x when x is a number from negative pi over 2 to positive pi over 2. And this is the domain of the restricted sine function. Now let's solve a few examples and see how we can apply these inverse properties. The first expression we have to simplify is sine of inverse sine of 0.7. In this expression, we start with sine and we have inverse sine in parentheses. Therefore, let's see if we could use the first property. Is 0.7 and the interval from negative 1 to positive 1? Yes, it is. Then, according to this property, whatever number we have here, that will be the result. Then we can say that sine of inverse sine of 0.7 is 0.7. Now, let's continue with the second example. Here we have sine of inverse sine of 5. Is 5 on the interval from negative 1 to positive 1? No, 5 is not in this interval. In fact, inverse sine of 5 is undefined. Therefore, the whole expression is undefined. In the next example, we have inverse sine of pi over 4. So this expression starts with inverse sine, and sine is inside the parentheses. Therefore, let's see if we could use the second property. Is negative pi over 4 in the interval from negative pi over 2 to positive pi over 2? Yes, it is. Then whatever number we have here, that will be the answer. So then we can say that inverse sine of pi over 4 is pi over 4. And now in the last example, we have inverse sine of 3 pi over 2. 3 pi over 2 is not in the interval from negative pi over 2 to positive pi over 2. Then in this case, this property will not work. In other words, the result will not be 3 pi over 2. We can still find the value of this expression, but we have to start by finding the value of sine of 3 pi over 2. If we want to use the unit circle for this, then sine of 3 pi over 2 is negative 1. And now we will have inverse sine of -1. Now we know that the value of the inverse sine function can be any number from -π/2 to +π/2. So on this interval from -π/2 to +π/2, what angle exists whose sine is -1? That would be -π/2, because at this angle sine is -1. Then we can write that inverse sine of -1 is -π/2. I hope you enjoyed the video and thank you for watching.